Okay, so here they're looking at some changes over months. We are on page 124, section 1.15. And so your start in real life is always at 0, and it's every month after that. So we're going to put month 1, 2, 3, 4, 5, and then go ahead and put these numbers in the chart, and then we're going to put again 0, 1, 2, 3, 4, 5, and put these numbers in the chart, and then try to decide whether they're arithmetic or geometric, and then we're going to try to come up with the formulas for those. So fill in the numbers, and then try to decide what's going on here. And I'm going to pause it for a second. Okay, so I tend to look for things that are arithmetic first if I can, which is like adding or subtracting all the time. Multiply and divide, I can figure out what it is, but then I have to think a little bit more. So like this one went up by 40.4.42. It's not going up by the same amount all the time. So like down here it's going up what, about 0.49, so, and then over here is 0.4. So I'm thinking this one's going to be geometric, but that means I got to figure out what they're multiplying by all the time, so I'm going to come back to that one. This one, if I look and I subtract, it looks like it's going down by 0.12 all the time, or subtracting, and I can try that, and yep. So if I subtract these two numbers, I see that it's always that common difference. So this one is definitely arithmetic. And so again, let's write our formula for this. So in the nth term thing, like we did the other day, except the nice news is in real life you start at 0. So in real life, my starting amount is 3.8. And again, remember that's in millions. And then we are losing, or repeat subtracting or repeat adding, that amount all the time. So if you want to add a negative because you're losing it, that's fine, or subtract, but it's repeat over and over and over and over again. And again, repeat adding or subtracting is the same as multiplication. So if I have like 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3, when you add over and over and over and over and over again, it's multiplication. So that's why I'm going to use n here. And I don't even need the parentheses there if I don't want it, because when a variable touches a number, it means multiplication. So I could just put my n there. I don't need n minus 1 because real life starts at 0. So like here is 1 subtraction, 2 subtractions, 3, 4, 5. So on the 5th term, I've subtracted 5 times. So if I'm at the nth term, I would have done it over and over n times. All right, now let's look up here. So it's changing all the time. So what I'm going to look for is what is the percent increase or decrease. And so remember what that is that's the change divided by the original number or the start. So like if I subtract these, I get 0.40, and you divide by the start. And so my start is what, 8. So if I divide those and again multiply by 100, it looks like it's about 5%. So I'm going to test that theory over here. I'm going to subtract, which is what, 0.42. Divide by the start or the original, so 8.4. So let me grab my calculator quick. So what do I have? So if I take 0.42 divided by what, 8.4, I get 5% again. And so I can keep checking that over and over and over again, but that looks like it's 5%. And in real life, it might be like, 4.9% sometimes, but it should overall be close to that. All right, so this is going to be geometric, which means it's repeat multiplying all the time. So my starting amount in real life, I start times 0, so I'm starting with 8 again. So 8.00, and again, this is what, billions. And I am repeat multiplying all the time. So I'm repeating multiplying by, and it is growing. So it's an increase of 5%. So that's 105% for a multiplier because it's keeping the previous value and adding 5%. And then my exponent goes up here because again, remember 8 times 8 times 8 times 8 times 8 is 8 to the 5th power. So when you repeat multiply over and over again, so when you multiply by 105, like here I multiply once, I multiply that answer again, and the next answer again, and the next answer again, and the 5th time, 1.05, running out of space here. So I have 1, 2, 3, 4, 5 times I'm going to multiply it if I'm at the 5th term. So if you take 8 times this 5 times, you should get that same answer. So that formula is going to work. So it's just like we did the other day, except you don't need the n minus 1. And if you're repeat adding, n is down low because repeat adding is multiplication. And if you're repeat multiplying all the time, it's exponential because repeat multiplication is exponential. All right, why don't we pause and why don't you turn to page 125? All right, so a function is something that you have an input and it predicts an output. So, for example, I put $1.75 in the pop machine, I push the Diet Mountain Dew button, I get a Diet Mountain Dew. So that's a function. I have an input, money, my output is a specific type of soda. Again, that's why if something doesn't work like that, we say it malfunctions. So like the computer could be I enter somebody's name, like Mary, and then I click a button, and then the output would be her grade. So maybe Mary has a 95% in my class, okay? It would be malfunctioning if I put in Mary's name and 2 different grades came up, and I'm trying to figure out which one's the right one. So a function, you have input, and you have output, and if you have 2 outputs, that's a problem. So you can have 1 input and 1 output. Now, could 2 people have the same grade? Could I input Joe's name and could he get a 95 as well? Sure, 2 people can have the same grades. It's just Mary can't have 2 different outputs. For every input, you get 1 output. All right, so if we look down here, there's an example of a function, all right? And so they give you a chart. Now, to write the formula, you would really have to go back in time. So that's, let's see, 20, 15, so I would need 10, 5, and 0. Because remember, real life starts at 0, okay? But let's look at what's happening. So this person is, if they work 15 hours in a week, they get this much, and so forth. So if you think about it, if they work 0 hours, they're going to make 0 money, okay? And it looks like under their 0, it says they get paid $15.75 an hour. So if they work 0 hours, you multiply it, they get 0 money. Okay. And again, this is my independent variable. This is my dependent. It spells ID. And independent goes here, works, and then the other here. Okay. So this is always going to be your X. So how do I write the formula? Like, where did they come up with this? Well, technically there's a plus 0 there. The starting amount is over here, $0. And then what are we doing all the time? We are repeat adding over and over and over again. Now, some of you might be like, but we're not repeat adding 1575. But see how this is a jump of 5? So if I subtract these and divide by 5, I'm going to get this 1575. So in reality, if my chart went by ones, at $0 or 0 hours work, they get 0. 1 hour, they would get 75. If they work 2 hours, I'd multiply by 2, 3 hours, 4 hours, and 5 hours. And that 5 hours, it would equal whatever. So because this chart goes by 5s, that's why these don't go by 1575. But if they went by 1s, starting amount would be $0 and you're making 1575, and you would keep adding it over and over and over again. And repeat adding is multiplication. And notice it's linear. So that's why there's no exponent. See how the n is down low? It's because when things are linear, they're all on the level. Everything's on the level. There's no exponential. All right, let's flip to the next page. Okay, so for this next one, it looks like they are gaining 500 customers every single quarter. So notice how they're adding, and so forth. So how do they come up with this formula? Okay. Well, in real life, you would start with how many customers? I have 0. So real life starts at time 0, but I have a value of 0 there. And then what am I doing all the time? Well, I'm adding 500 every quarter. So 500, 500. So again, if I keep adding 500 to the original amount over and over again, that's multiplication. So I'm repeat adding, and depending on how many times, n times. Now, again, it's a constant amount. It's arithmetic. Do you see how it makes a line? It is linear. So your n has to be low. And again, there's no n minus 1 because we started at 0, so we're all good. If this was multiplication, then we would repeat multiplication, then we'd have an exponent there. But this is definitely linear. All right, let's look at the next page. Okay, so again, you might want to read this here. But again, linear growth is when it's kind of like a positive correlation. It's one's going up, the other one's going down. Linear decay, linear decay, the one on the right here, would be like a negative correlation. As one goes up, the other goes down, or vice versa. As one goes down, the other one goes up. So that's how those look. Let's look at the next page. All right, so let's look at the top one here. Actually, I'm going to take a picture and come right back. Okay, so try to figure this on your own. Try to write the formula for number 2. So pause it and then come right back. Okay, so you have to see if this is geometric or arithmetic, so which is the same as kind of linear or exponential. So what's happening here? So it looks like I'm what? Adding 6 all the time. So adding 6, adding 6, adding 6, adding 6. So real life starts at 0, which is lovely. All right, so I'm starting at what value? A negative 18. All right, so my time is 0, but my starting value that goes at time 0 is negative 18. And then what am I doing? I am adding, what am I adding? 6 over and over and over again. So if I'm on the 5th term, how many times have I added 6? 1, 2, 3, 4, 5. So I just have n. I don't need n minus 1 because if you start at 0, it matches perfectly. You don't need the fix, okay? And so this would predict, like if I wanted to know the 10th term, I would just shove 10 in here, a negative 18, and 6 times 10 is 60. So what is it? 42. So the 10th term is going to be 42. So if I keep going on the chart 6, 7, 8, 9, 10, I should get an answer of 42. All right, why don't you pause and try to do number 3 and try to graph it as well. So try that one. Okay, so let's look at this. You have a loan of $800 and you're not getting charged any interest and you're just going to pay off $50 every month. So at time 0, how much money do you owe? You owe, this is amount left to pay, so $800. And then you're going to just keep paying $50 over and over and over again till eventually you get it paid off. All right, so this is your independent variable. This is dependent, always spells the word ID. So X goes here. Months makes sense. 0 has to start here, and it just makes sense to do, well, that's not the most consistent, but 1, 2, 3, 4, and 5. Just because my numbers aren't that big. And my label on that is months. All right, and this would be what? Maybe my loan repayment. Something like that. All right, and then these guys go here. Now, I might want to do the zigzag thing, or I might not. Kind of up to, you know, how you want to do this. So, I mean, going by hundreds isn't bad. So if you do the zigzag thing, then you'd have to start maybe at like, say, 400 and so forth. I'm just going to go by hundreds. So 100, 200, 3, 4, 5, 6, 7. I need to extend a little bit, 8. And this would be money. What is that? The money owed maybe would be the amount. Okay, so $100, 200, 300, 400, 500, 600, 700, 800. All right, so when we start out, we have owe 800. Then after a month, we owe what? Halfway, 750. 2 months, we owe 700. 3 months, we owe what? 650. And I'm kind of off on the screen. I apologize. It's hard for me to sometimes visualize these very well. 4 is going to be 600. And then 5 is going to be 550. So again, if you have, well, you don't have graph paper either, but there's kind of a distortion here on the screen. So eventually, I'm going to pay off that debt. Now, what about the formula? Well, real life starts at 0, which is great. What is my starting amount? 800. And then what am I doing all the time? I am subtracting 50 over and over. Or you could put add and negative 50. That's up to you. All right. And then it's repeat adding, which means it's multiplication. Because I'm doing negative 50 1, 2, 3, 4, 5 times to get that answer. So I would need to have 5 sets of that. And again, this is definitely linear. And it is a negative correlation. So the more months I pay money, obviously my debt, goes down because I'm slowly paying off my loan. All right, let's look at the next page. Okay, so I'm going to start my next video with this one. So you might want to look back at example 2 maybe, the bottom of the page here, and just read this scenario where a virus is infecting some people, and then I'll pick up here in our next video.